This is the story of the Kola superdeep borehole, the deepest borehole ever drilled by humankind. 12 kilometers and 262 meters deep, a record that remains unbeaten to this day.
For decades, scientists believed they understood the layers beneath our feet. But when Soviet engineers drilled deeper into the Earth than anyone ever had, they unearthed shocking evidence that defied every textbook and assumption. What they found was so unexpected, it forced a silence that lasted years, raising the question, what truths were too dangerous to share? Could water and fossils really exist miles beneath the surface, in temperatures over 350 degrees Fahrenheit? And why did the Soviets keep these revelations hidden for so long? This story is more than geology. It's a glimpse into the clash between ambition, discovery, and control, breaking records and expectations. In May 1970, deep beneath the border of Norway and Russia, Soviet engineers fired up a drilling rig with an ambitious goal: to drill deeper into the Earth's crust than anyone had ever dared. This was no ordinary project. It was a race against time, technology, and even the United States, which had previously attempted a similar venture known as Project Mohole. The Soviets were determined to reach 15,000 meters if possible, far beyond the capabilities demonstrated by their rivals. The team believed this mission would unlock secrets about the very structure of our planet. The first stages of drilling went smoothly, with the rig steadily biting through solid granite. Scientists closely monitored every inch, collecting core samples and noting temperature and density measurements. For thousands of meters, everything aligned perfectly with established geological models. The team passed 3,000 meters, then 5,000, celebrating small triumphs along the way. Their spirits were high, buoyed by early success and the promise of even greater discoveries. Yet, around 7,000 meters, unexpected anomalies began to emerge. Geophysicist Elena Kuznetsova noticed something that didn't fit the textbooks. According to decades of seismic surveys, the drill should have encountered a transition, the Conrad discontinuity, where granite converts to basalt. But instead, all they found was more granite. This wasn't just a small irregularity. It outright challenged their understanding of Earth's layered composition. To question this fundamental assumption was to risk shaking the very foundation of Soviet geology. Elena brought the findings to the project leader, Alexei Sokolov, who regarded the report with growing concern. Rather than share the troubling data widely, he locked the report away. The potential consequences were enormous. Admitting the data was wrong could undermine decades of research and expertise. The team agreed to proceed cautiously, knowing that revealing the truth might disrupt the entire field. But hidden beneath the surface, greater surprises awaited. By 1979, the Kola super-deep borehole had shattered records, surpassing any previous depth achieved by drills around the world. Yet the celebrations masked the scientific team's rising unease. Their core samples revealed anomalies not just in rock layers, but in the unexpected presence of water and gases where none should be. Each discovery contradicted the conventional narratives scientists had accepted as truth for years. What should have been straightforward drilling into solid rock was turning into a puzzle fraught with unexplained phenomena. 4,000 meters down, researchers began handling rock samples that felt damp to the touch, an unsettling indicator. The pressure and heat at these depths were thought to preclude liquid water from persisting. Yet here it was, trapped inside microscopic fissures, defying every previous assumption. This unexpected moisture suggested a highly porous, interconnected crust, rather than the impervious barrier it was believed to be. The nerve of questioning these findings lay in how deeply they cut into established models. Then came a massive setback. At 12,000 meters, a critical piece of drilling equipment twisted off and plunged into the hole, forcing the team to start again from 7,000 meters. Loss of years' work was devastating, but the engineers' resolve remained firm. They pressed onward, driven not just by national pride, but by the possibility of uncovering Earth's hidden truths. Their perseverance set the stage for some of the most astonishing revelations in geology. By 1989, the drill had reached 12,262 meters. the deepest point humans have ever penetrated into Earth's crust. It was at this staggering depth that Victor Petro examined a core sample unlike any before, tiny, perfectly preserved organic fossils embedded in granite. This discovery defied everything known about life's limits under crushing pressure and searing heat. What it meant for geology and biology was profound, and would become a source of controversy that lasted decades. The drilling at Kola proved that beneath what we thought we understood lies a world full of surprises. But some of these truths were too unsettling to share openly, buried for years under caution and silence. What was uncovered at the borehole was not just an achievement of depth, but a challenge to the fundamental ideas about Earth's inner nature. The mysteries began with geology, but soon reached into the very fabric of life and water beneath our feet. The missing basalt layer mystery. The expectation going into Kola was clear. At approximately 7,000 meters deep, the drill would pass through a significant geological boundary known as the Conrad discontinuity. This zone marked the shift from granite to basalt, a fundamental layer change that defined how scientists understood Earth's crust. Yet, when the Soviet drill passed this depth, the basalt layer simply wasn't there. Instead, only more granite greeted the core sample. This anomaly was both baffling and deeply unsettling. This missing layer wasn't simply a detail to be overlooked. Seismic studies, which had guided geological interpretations for decades, clearly predicted a basalt transition at this point. The absence suggested one of two possibilities. Either the seismic data was flawed, or the accepted geological models were incomplete or incorrect. Either explanation rocked the very foundation of Earth sciences, calling into question global understandings of crustal composition. For the Soviet team, this posed a dilemma. Admitting that the doctrine was wrong risked damaging hard-won credibility. Mountains of research, textbooks, and scientific policy were built on these seismic interpretations. A public contradiction could imply failure or worse, undermine national prestige in a Cold War climate where scientific superiority was a point of pride. This made the data sensitive beyond pure academic concern. The geophysicist who uncovered this inconsistency urged caution and further study. The initial reaction was to keep findings internal, avoiding premature announcements that could alarm officials or invite scrutiny. The drill pressed on, but the question loomed. What else might the Earth's crust be hiding, beyond the accepted scientific narrative? As drilling progressed, additional anomalies surfaced that only deepened the mystery. The crust appeared less uniform and more complex than the neat layers textbooks described. Scientists began to realize that direct sampling offered realities far different and messier than seismic models predicted. The discrepancy between observation and theory grew impossible to ignore. This geological surprise was not unique to Kola. Similar results emerged in later deep drilling projects worldwide, indicating that Earth's interior might be far more heterogeneous and dynamic than once believed. The old framework required substantial revision to incorporate these new findings and to understand the true architecture beneath the surface. But at Kola, the missing basalt layer was more than a scientific challenge. It was the first crack in the carefully maintained narrative. It introduced doubt that would ripple through every discovery that followed, setting the stage for revelations far more profound and difficult to hide. Even as questions multiplied about rock layers, something even more surprising awaited in the depths. The presence of water, where none should exist. Unexpected water, deep below. When a damp core sample was pulled from around 4,000 meters down, it surprised everyone. At that depth, under extreme pressure and temperature, scientists believed liquid water could not survive. The rock was expected to be dry and impermeable. Yet, here was water seeping through microscopic cracks and fissures, defying standard geological assumptions. This discovery hinted at an interconnected porosity in the crust that no one had fully appreciated. Further analysis revealed that this water wasn't newly formed. Instead, it had slowly percolated down from the surface over millions of years. Complex pathways in rock, previously thought impermeable, provided routes allowing groundwater to seep deeply into the crust, eventually becoming trapped at immense pressures. Researcher Elena calculated that the water reached a depth where the physical forces balanced out, leaving the liquid essentially sealed in place. This reality directly contradicted earlier models, which had stated such water couldn't exist so deep. The implications were enormous. If water exists in these crustal depths, it could influence rock mechanics, chemical reactions, and even geothermal energy flows in ways previously unconsidered. The permeability of the deep crust could affect earthquake processes or the transport of minerals. Moreover, deep water opens intriguing questions about habitats for life far beneath the surface, life that might rely on subterranean water reservoirs. Yet, the revelation was also problematic politically and scientifically. Embracing these findings would require overturning long-held beliefs and admitting that Soviet geological doctrine was incomplete. Officials blocked early attempts to publicize the discovery, fearing it would undermine scientific authority. This water was a secret too disruptive to share easily. Meanwhile, as the drill pushed beyond 12,000 meters, temperatures soared far beyond expectations, complicating the understanding of how materials behaved deep below ground. But the presence of water continued to challenge what was thought impossible in Earth's hostile depths. The peaceful image of dry, solid rock gave way to something more dynamic and surprising. Discovering water miles beneath the surface foreshadowed another astonishing find: organisms preserved in conditions thought unlivable. The deeper they drilled, the more they realized our planet's interior held secrets that science had only begun to grasp. Fossils 12 kilometers down. At 12,200 meters beneath the surface, the Soviet drilling team reached a level no human had explored before. But what awaited them surpassed even their wildest expectations. Viktor Petrov, examining core samples under the microscope, discovered something extraordinary: microscopic fossils embedded in the granite. These weren't just any fossils, they were single-celled marine plankton, remarkably preserved despite the crushing pressure and extreme heat. The find was staggering, challenging everything known about life's endurance deep within the Earth. The presence of organic material at such depths was considered impossible. Temperatures there soared above 350 degrees Fahrenheit, conditions scientists believed would obliterate any trace of life. But Victor's meticulous analysis confirmed the fossils were genuine, and multiple samples reinforced that conclusion. This discovery shattered the assumed thermal limits for organic preservation and opened a door to questions about life's resilience and the Earth's history. The news ignited debate and disbelief among the research team. Some were quick to dismiss the findings as contamination or error, hesitant to accept such a radical anomaly. Yet, the evidence was irrefutable. If life had been preserved at these depths for billions of years, what else might exist deep within the planet's crust? It was a humbling reminder that our planet's interior held secrets far beyond current scientific models or expectations. For the Soviet authorities, however, the implications of the fossils were inconvenient. Publicizing this information risked undermining decades of published research, calling into question the accuracy of the thermal models that had long guided geological theory. Officials urged caution, instructing scientists like Victor to keep the findings under wraps until they could consult higher-ups. The data was too explosive, too disruptive to the established narrative. This suppression reflected the collision of scientific discovery with political priorities. The Soviet government maintained strict control over information, especially findings that could be seen as contradicting official scientific doctrine. For decades, vital pieces of knowledge, like the fossils, were quietly shelved, hidden beneath layers of bureaucracy and silence. This shadow over the research slowed the progress of understanding Earth's deep biosphere and challenged norms about transparency in science. Beyond the fossils themselves, the discovery sparked new questions about Earth's past and the origin of life. If organisms could survive, or at least be preserved, under such hostile conditions, what did that mean for theories about how life began and evolved? It expanded possibilities for life in extreme environments, not just on Earth, but potentially on other planets with harsh subterranean conditions. The implications reached far beyond geology and biology. The Kola Borehole's fossil discovery also shifted scientific thought about the interactions between the biosphere and geosphere. It pointed to a more complex and enduring relation between living organisms and Earth's deep interior, than previously imagined. Such fossilized evidence suggested that the planet's subsurface might be home to microbial ecosystems, sustained by unknown processes for eons. Despite the pushback, the research slowly gained traction among the global scientific community. As similar findings emerged in other deep drilling projects worldwide, the presence of life or its remnants deep inside Earth became harder to dismiss. The Kola fossils had opened a new frontier, urging scientists to rethink the limits of life and the dynamic conditions far beneath our feet. As astonishing as the fossils were, they weren't the only anomaly troubling researchers. The unexpected bubbling of hydrogen gas in the drilling mud was another enduring enigma. Hydrogen bubbling up. One of the most perplexing discoveries at the Kola superdeep borehole wasn't a solid rock or fossil. It was the drilling mud itself, saturated with hydrogen gas and bubbling as it emerged from the depths. Dmitry Vulov, who studied this phenomenon, remarked on how the hydrogen concentration far exceeded all predictions. It literally bubbled like liquid boiling, but temperature was not the cause, a mystery that defied straightforward explanation. Where the hydrogen originated became a central question that puzzled the project team. Two primary theories emerged. Either an unknown process deep within the crust was generating hydrogen, or the gas had been trapped in the rock for millions of years and was only now released by the drilling. Neither explanation fits neatly within existing geochemical frameworks, leaving researchers with more questions than answers. Hydrogen's presence had profound implications. It suggested active chemical reactions were taking place far beneath the surface, or that the crust's storage capacity for gases was significantly underestimated. This could impact not only geological processes, but potentially even deep ecosystems relying on hydrogen as an energy source. The findings hinted at a dynamic and chemically reactive Earth interior quite unlike the inert, static picture presented in textbooks. Despite its significance, this hydrogen discovery was treated cautiously by the authorities. It was another inconvenient fact that challenged accepted scientific models, and early attempts to publish or discuss it publicly were met with resistance. The Soviet government sought to contain the narrative, wary of implications that might undermine their scientific prestige or political image. The drilling mud's hydrogen content was more than a technical curiosity. It became a symbol of the unknown processes still hidden in the Earth's depths. Scientists began to realize that the deep subsea floor and continental crust might harbor complex geochemical environments capable of sustaining life and influencing Earth's long-term evolution. Together with water trapped far beneath the surface and fossils found in crushing heat, the bubbling hydrogen painted a picture of a remarkably active and interconnected crust. It suggested that Earth's interior is not simply a cold, lifeless mass, but a chemically diverse realm with surprising fluid and gas dynamics. These chemical mysteries added layers of complexity to the challenges engineers faced when pushing the drill ever downward amid rising temperatures and shifting rock behaviors. Each new discovery underlined how much remained unexplored and unappreciated about our planet's interior. The hydrogen bubbles and their enigmatic origin remain one of the most fascinating questions raised by the Kola superdeep borehole. Nature's whisper from the depths, hinting that beneath the surface lies a world vastly different from what we assumed. Extreme heat and plastic rock. As the drilling ventured deeper, the team faced a formidable and unexpected challenge. The Earth's temperature at these depths was far hotter than predicted. Scientists had anticipated a gradual increase, expecting temperatures around 210 degrees Fahrenheit near 12,000 meters. Instead, instruments recorded readings exceeding 350 degrees. This steep temperature gradient was a jarring surprise that forced a re-examination of thermal models used for decades. This intense heat had a profound effect on the rock itself. Rather than behaving as a hard, brittle material that would fracture cleanly under the drill, the granite began to act more like plastic. It deformed and flowed under pressure, losing its rigidity and creating a soft, pliable environment. This new reality made drilling extraordinarily difficult, as the rock no longer responded predictably to the tools designed to cut through solid stone. Engineers tried everything: different drill bits, varying speeds, and numerous compositions of drilling mud. But nothing prevented the rock from bending and flowing like warm clay. The unexpected plasticity slowed progress, led to equipment failures, and raised uncertainty about whether the operation could reach its ultimate goal. Attempts to move deeper faced a natural barrier. This transformed rock was almost impossible to penetrate reliably. At a crisis meeting in June of 1990, project leader Alexei Sokolov summarized the dilemma plainly. The heat was making the rock behave like plastic, and the drill could no longer cut effectively. The obstacles were not technological, but geological, a reminder of how little was truly understood about Earth's inner mechanics. Though the team considered starting new drilling branches from shallower depths, optimism dimmed as the problem persisted at every level. Repeated efforts continued into the early 1990s, with the team opening fourth and fifth drill branches. Yet the rock's heated softness remained an insurmountable challenge. Each attempt ended in equipment damage and unwanted delays, underscoring the limits of existing technology and the complexity of Earth's interior properties. These setbacks coincided with a changing political landscape. By 1994, the Soviet Union had dissolved, and funding for the project was cut dramatically. The ambitious mission that once symbolized national pride and scientific prowess was abruptly mothballed. What might have been the crown jewel of deep Earth exploration was left unfinished, its deepest penetrations permanently sealed. Though the operation stopped short of its 15,000-meter goal, the extreme thermal findings dramatically shifted scientific perspectives. They revealed that Earth's crust was not a simple static environment, but a complex, dynamic system with physical properties that change unpredictably under intense heat and pressure. The plastic behavior of rock at depth challenged universally held assumptions. The temperature anomaly also had implications beyond drilling difficulties. It suggested new thermal energy flows within the Earth, influencing models of plate tectonics, volcanic activity, and geothermal resources. Understanding this extreme environment became essential for geology, reshaping how scientists viewed the planet's inner workings. The struggle with heat and plastic rock was a harsh lesson in Earth's complexity, but it also set the stage for conflicts beyond the scientific realm. Conflicts that affected how and whether these discoveries would ever see the light of day. Political pressure and silence. Despite the profound scientific revelations emerging from the Kola superdeep borehole, the Soviet government responded with restraint and secrecy rather than celebration. Many of the findings, from missing basalt layers to water deep underground to fossilized plankton and hydrogen bubbling in drilling mud, contradicted decades of established geological doctrine. Admitting these discrepancies threatened not only scientific credibility, but also political prestige during a time when controlling narratives was paramount. Inconvenient discoveries that scientists wanted to publish or discuss were met with resistance and even threats. Some of the researchers were simply advised to remain silent, while others had to face the risk of being transferred or suspended. Dmitry Vulov, for instance, had his security clearance revoked for half a year after making an attempt to present his hydrogen findings internationally. The implication was evident. The truth was to be kept inside the Soviet Union and controlled very tightly. The political pressure enforced a self-censorship attitude among the scientists, who, in a way, had to draw a line very carefully between the discovery and the obedience. Openly disputing the scientific orthodoxies would likely lead to the shutting of the doors to future research opportunities or even the ruining of careers. Thus, the data over Kola had been controlled for so long that the world had hardly ever become aware of it, and discussions in the international scientific community were also delayed for years. Although the researchers had the knowledge about the Earth's interior that no one else had, no one would get it for a while since the world had moved on. The researchers kept the doors of the laboratories shut, but were fully aware of the revolutionary effect of their work. They realized that the currently accepted models worldwide assumed about Earth's interior were either incomplete or wrong. However, The release of such disruptive information would not only challenge the scientific theories, but also imply the Soviet Union's downfall in terms of propaganda and superiority. This complex intersection of politics and science led to years of delays and miscommunication. The hesitancy was not only the result of an ideological war, but it was also the result of fears that reversing the accepted knowledge would cause the destabilization of the industries, the educational systems, and the international reputations. The Soviet leadership was more concerned with a unified narrative than with the uncertain truths. The perception of science being a political tool was prevailing, and the facts that were not in favor of the narrative were regarded as commitments that had to be managed. The Kola case presents the situation where the power and truth are interwoven in such a way that the political interests can delay or distort the acceptance of scientific truth. It also reminds us that access to knowledge is not only restricted by technological limitations, but rather by human agendas. The huge piles of data that had been kept in storage for decades are a record of how the controls have affected the progress in science. The Kola Borehole, despite a number of attempts to ignore and cover the fact, cannot be said to have silenced the core samples and their story. This drilling project, therefore, symbolizes human curiosity at the mercy of political realities. But still, it tells us that sometimes the greatest barrier in understanding is not nature, but rather the walls that we construct around the truth. Though science struggled against silence, the planet kept revealing its secrets, pressing the question of what awaits discovery beneath the layers still unexplored. Legacy and lessons learned. The Kola superdeep borehole finally stands as a monument not to reaching an exact depth, but to the unexpected lessons it taught humanity about the Earth beneath us. Although the drilling never reached its 15,000-meter goal, the discoveries made along the way compelled scientists to rethink many long-held geological beliefs. The project shattered the illusion that we fully understood the structure and conditions of the Earth's crust, exposing a reality far stranger than we imagined. One of Kola's main legacies is that it proved the limitations of indirect observation. The core of the Earth could only be seen as the result of almost 30 years of indirect observation, guessing, and theorizing. Among the discoveries were things that even discovery by direct sampling could not resolve, such as the absence of certain rock layers, the presence of surprising water and fossil remains, and so on. Theoretical models based on indirect observation had to give way to the more complex reality of the crust henceforth. The project also highlighted that political agendas could greatly slow down scientific progress. Geological data of high value was either suppressed or ignored because it did not fit the doctrines that were connected to national pride and ideological narratives. The delay in revealing inconvenient truths continued slowly to the east, where geology was already facing difficulties. Hence, if it were only the case of talking, geologists of different parts could not see or just realize the truth of the Earth's crust being so disparate. Nevertheless, scientists, after free publishing, were able, with Kola's results, to One of the major benefits of the Kola discoveries was that they prompted other nations to take up deep drilling projects of their own, in Germany, Sweden, and Austria. A lot of these projects ran into similar anomalies as well. This force of parallel projects can be seen in the gradual mellowing of skepticism towards the Soviet borehole and the gradual establishment of a new scientific paradigm. Kola's experience stands today as a point of reference for the future potential and challenges involved in deep Earth explorations. The drilling also put forward basic concerns as to the origin and existence of life limits. The fossils found were an indication that organic matter might endure even the most dreadful conditions. Thus, the range of life's resilience was increased. This scientific breakthrough has and will continue to cause the re-examination of the Earth's interior as capable of harboring microbial ecosystems still unknown to science, hence directing the research in astrobiology and deep biosphere studies. Kola, in its entirety, technologically brought about advancements in the fields of engineering and drilling methods. The heat and the changing nature of rocks made them plastic-like, thus creating major problems for the innovators who were trying to penetrate deeper into the Earth. Meanwhile, engineers and scientists, to whom the problem was not a hindrance but an opportunity, continue to work on new tools and techniques, hoping that one day they will break through the Earth's mantle and unravel even more mysteries that are not accessible but are at least close enough to be hinted at. The superdeep borehole is still closed, but its silence is proof of both human aspiration and humility. It tells us that the Earth is still hiding enigmas under the surface of every layer, which are waiting for the daring ones to come and discover them. The questioning process that every core and every astonishing sample taken from the abyss brings about is the one that reshapes our understanding. When the researchers of the Kola project study the data and samples coming from the Earth, that is decades after the drilling has stopped, the impact of Kola still echoes in the geological labs and the conferences worldwide. The project not only showed the affirmation of the previous misunderstanding that is needed in the process of coming up with new truths. Kola's primary gift to the science world might be the very message it sent. Science cannot survive on the false basis of confirmation of the already existing beliefs. It has to reveal the error in such beliefs. The borehole not only gave access to the Earth's interior, but also to scientific modesty and an insatiable thirst for knowledge. Beyond its immediate scientific outcomes, the Kola super-deep borehole reshaped how large-scale scientific ambition is evaluated and justified. It demonstrated that projects of extreme scope do not need to succeed in their original objective to be valuable. Instead, Kola became a case study in adaptive science, where unexpected results were not failures, but catalysts for new questions. Finally, Kola's legacy endures in the philosophy of exploration itself. It serves as a reminder that Earth, despite centuries of study, remains an active frontier. The borehole reinforced the idea that true discovery often lies at the edge of technical capability and intellectual comfort, where assumptions are most vulnerable. In this way, Kola transcends geology. It stands as a symbol of humanity's ongoing dialogue with the unknown, urging future scientists to probe deeper while remaining open to being surprised. The Kola borehole taught us that Earth's interior is far more mysterious than we imagined, filled with unexpected water, fossils, and heat that defied all predictions. Its legacy is a powerful reminder that discovery often comes from what surprises us most. If you enjoyed uncovering these hidden truths, please like and subscribe for more stories that challenge what we think we know. Thanks for watching.